All right, welcome back. So, what do I mean by algorithmic accountability? Well, it turns out that many algorithms express biases. And by bias, I'm not talking about the bias term in the weight vector. I'm talking about a bias in terms of racism or sexism or any other kind of discriminatory kind of thing that's looking at human beings being better or worse than other human beings. Here's an example from 2016 that kind of was all over the machine learning internet. So somebody noticed that if you type into Google image search, and Google search is fundamentally an AI thing, right? It's using an algorithm to try to come up with some sort of formulation of your answer and produce search results for you. So what is that algorithm doing? It turns out if you type in professional hair, you get white people, and if you type in unprofessional hair, you get people of color generally, right? That seems rather discriminatory. Why is it that Google has got this racist image search, right? Well, obviously the image search was not programmed to be racist. What is it picking up on? Anybody? Bueller? You're right. Thank you very much, person in the front row who's always participating. So what it's picking up on is the data we generated, right? There are all kinds of chat rooms and things on the internet, whatever, and in those are all kinds of natural language that is being learned. So somebody put unprofessional next to a picture of a woman with dreads, and therefore when Google searches for the word unprofessional, it believes that that woman with dreads picture is an appropriate picture. So we are racists, and we display our racism on the internet in data which gets sucked up into Google's algorithms. And Google's algorithms then, when queried with things that are the right term to show that racism encoded in all of its data, will show the racism encoded in its data. And it's interesting too, it goes beyond that. So if you do this trick now, it still kind of works, but what you also see is loads of pages of people discussing this. So like this Guardian article that I pulled this image from, like it pops up in the image search. But it still fundamentally works because the overwhelming examples of data that are out there are still the way they are. So another example is that Amazon several years ago tried to train an AI to help out with recruitment. They wanted, they were getting so many resumes that they didn't have enough human resources people to go through them. So they're like, let's train an AI to narrow down our choices. And it turns out that what they trained it on is they trained it on the hiring history they had for the 10 years previously. So from like 2008 to 2018, turns out Amazon mostly hired dudes, right? And therefore, the algorithm learned that women don't make good hiring candidates. And therefore, it discriminated against women. And you throw two resumes in, right? One, they have the identical setup on them, but it's just that you replaced a male name with a female name. And the female name would not get through this filter, but the male name would. So another problem with that, by the way, is that you have counterfactuals. If you assume that your past history of hiring gets you good employees, you really have no idea, right? You never tried the employees you didn't hire. You have no idea how good those employees would have been. Those employees could have been better than the employees you hired. So starting with history and calling it truth is a terrible idea in general. Okay? So that's something called a counterfactual. You don't know what would have happened if you would have hired person B you didn't hire. Okay. Another example, this paper from, oh gosh, I don't even remember, 2014 maybe. So when you do name searches, you would be served Google ads, right? Like, look up this person, pay this web service money to find this person's address. And sometimes it was also, pay this web service money to find this person's background check. So they just searched for names in Google, and the AdWords were coming up, right? The AdWords, these ads on the sides of Google. And it turns out if you search for white-sounding names like Kristen, then you get served ads for, address lookup. And if you, search black-sounding names like Latanya, then you get ads for background check. And is this person a criminal or have they been arrested? Why is that? Well, here's what happened. At some point, landlords are Googling their tenants. And randomly, in the process, they're served up sometimes ads for background check. Well, if a landlord is a racist, then they're more likely to click on that ad, right? The background check ad, when the name that they searched for in the first place was black. All right? So then Google learns, oh, these kinds of names, we get good click-through rate on our ads when we serve those ads, right? It's a totally reasonable algorithm. I want to maximize click-through rate to maximize profitability. So I'm just going to look out there in the natural experiments of the gazillions of Google searches a day, and I'm going to try to link up, search terms that often produce a click-through with the right kind of ad to produce that click-through. It's just what Google Ads does. But in this case, because there's racists out there who are more likely to click on the background check for a black name than a white name, it filters up to everybody else. Okay. Another example out there these examples so far have all been, let's call them mild, right? There's nothing particularly awful about, it's demeaning, right, to have your hair labeled unprofessional, but it's not endangering, right? But algorithms endanger people too. They create real danger, deaths, and destruction, not just, this kind of, let's call it a milder form of racism. Okay? So there's algorithms out there that are involved in the criminal justice system. Two famous ones are predictive policing algorithms and algorithms that help judges decide if somebody in their courtroom is likely to reoffend and whether they should be given bail or put in jail or whatever, or put on parole. Okay, so the background is this. We've collected crime statistics for a long time, and if you look at the statistics, you can see where crimes happen, right? And police already know this, and police already tend to know, like, this is my bad neighborhood, this is my good neighborhood on my beat. I know that I have to be a little bit more careful over here than over there, right? But this is formalizing it into a citywide algorithm or a statewide algorithm. And then the idea is that it can take this historical data and tell you where to send your officers for preemptive patrols and when, right? Like stuff kicks off over here at this, area with lots of bars at about 1 a.m. So we should probably send some cops over there around 1 a.m. to try to prevent trouble. All right, how is this a problem? Well, it turns out that there's already bias in how police enforce the law. So an example of this is that blacks are arrested for marijuana possession at about 4 times the rate of white people. But yet it's been shown that black people are no more likely to use marijuana than white people. So if the usage rates are the same between blacks and whites, but yet blacks are much more arrested, what it is it's evidence that police spend a disproportionate amount of their time policing minority areas that are kind of, down economically, where there's might be lots of other kinds of crime, right? So the cops are already there. The cops are already there looking to deal with other kinds of crime. And therefore, when they see a street deal going down, then they make arrests. Or they engage in random stops of people in these higher crime areas, and therefore they make more marijuana arrests, right? So if you're an activist, you're going to see this as over-policing, right? So the police are in these areas for no good reason. Like, the activist viewpoint is that, yeah, you're enforcing the laws here in this region, but, if you went and looked over in the rich people land, you would see lots of coke deals and people doing white collar crimes and stealing money from embezzlement, right? Maybe you're not going to see a lot of, various other kinds of graffiti crimes and whatever in La Jolla, but you're going to see there's going to be crimes there. They're just not getting enforced. The cops are not there patrolling the kinds of crimes that are in La Jolla, but they are out there patrolling the kinds of crimes that are in, the East Village or something like that in San Diego. All right, so the cops are there. There is a lot of policing happening. Okay, because the cops are there, they're making more arrests. And because they're making more arrests, the data indicate this region has a higher crime density. The next step is that we set up a predictive algorithm to tell the cops where to go, and it's therefore going to predict higher crime there, and it's going to send the cops there more often. Because the cops are there more often, they are over-present and over-policing these areas, and they're making arrests disproportionate to the level of offense. They're not spending their time in other regions, right? Which means they're not making arrests in those other regions, which means the data indicates that it's a lower crime density there, even though the actual crime rates may be the same. And the cycle is a vicious positive feedback cycle, basically ending up with the cops always being sent to the same poor neighborhoods. So another example of this is a system called Compass. So Compass is a sentencing algorithm, and the idea is that it's there to, it's there to help judges make decisions about whether somebody should be sentenced to jail or put on parole, whether they should be held for a bond and allowed to, leave under a bond, or is kept in jail. So this is an excellent article on ProPublica about this, that where they took a deep dive into this system. So the Compass system is set up to make predictions of risk scores, right? And so what you see is that people were given a risk score of either low or high. And if you look at why, it doesn't make any sense given like the crime elements. So Prater, the white guy on the left, had 2 armed robberies and an attempted armed robbery, and later committed grand theft after being paroled. But Borden on the right had 4 juvenile misdemeanors and never committed an offense, yet she was rated much, much higher than he was, as a higher risk. Why is that? Well, it was using all kinds of other information about somebody that didn't have anything to do with their crimes, right? This risk assessment was taking into account things like the neighborhood they came from, right? What their circumstances were in their life, not just the crimes they committed. So there's formula were particularly likely to end up flagging black defendants as risky, right, at twice the rate as the white defendants. So, you see this over and over again, that the white person gets away with it and the black person gets flagged as high risk. So this is an interesting read, and you can take a look at it on your own. I highly suggest it. I think one of the, rather than going for the anecdote stuff, showing you the results, is that when prediction fails, it fails differently for black defendants, right? So 44% of black defendants were labeled higher risk but didn't reoffend, compared to 23% of whites. And on the white side, it's the opposite. 47% were labeled lower risk and did reoffend, whereas it was less than 30% for the black parolees. Okay? So it's clear that this algorithm was biased. Now the problem is that nobody knows what the algorithm is. It's not transparent. It's not accountable. Nobody knows how this system works. It's a trade secret. And nobody was ever briefed on this. Nobody could double check it. It was only after looking at its effects and the widespread discrimination that it had been engendering for years that anybody thought to question it. Right? So machine learning algorithms can harm. They can do real harm. So Cathy O'Neill is a data scientist who has written kind of a really important book called Weapons of Math Destruction. And in it, she lays out how these kinds of algorithms, these kinds of setups that lack accountability, that lack transparency, that have potentially huge impacts on people's lives, can implement our racist biases at huge unprecedented scales, right? One racist person has a hard time affecting dozens of people, but one racist algorithm, and wasn't designed to be racist, but it was ending up racist because it was built on historical data, and historical data reflects our society, and our society has elements of racism in it, right? So that generates bias in algorithms, and that bias can be operating now at machine efficiency and machine scales, impacting tens of thousands, hundreds of thousands, or even millions of lives. So this is how, what she calls a weapon of math destruction, right? They're able to do these things at scale. And even worse than that, people oftentimes say, well, it's fair. It's just an algorithm. It's just math, dude, right? It's, it must be true that these people are doing worse offenses because that's what the math says, and math is objective. Well, you and I know at this point that that's not true. But for somebody who is not skilled in understanding how this works, it can look like a good argument, and it gives this kind of veneer of objectivity to decisions where you might at least question a judge handing down a bad sentence like that, going, but nobody thinks to look side-eye at an algorithm handing down a bad sentence. So just to kind of close us out, I want to say that it's important that we think as machine learning people about what kind of world we want to live in, right? Is it our job to fix this, right? Some people will take the approach that, look, I'm just here doing the science. I'm just here being a computer science person. I'm just doing my job. It's not my job. It's somebody else's job. But the problem is that you as the machine learning engineer, or you as the person doing a data analysis, you're the one who knows, right? You're the one in a position to fix it. So always saying it's somebody else's job well, that's a moral stance that you are allowed to take, but it fundamentally, you know, from my standpoint, it fundamentally steps away from our personal responsibilities. So, you know, it is your responsibility to, anytime you are working on a system, I think, to make clear to yourself what is going on here. Is this the kind of world I want to live in when this system is created? Does it make sense to me that I want to implement my algorithms this way? Are there any kinds of underlying biases in the data I'm being fed that I need to do some sort of engineering on to try to fix it before it becomes a problem at scale? Okay? So Timnit Gebru is a rather famous researcher on AI ethics, and in fact, you might want to Google her name because there's been a lot of interesting drama around Timnit recently. And for those of you that like the kind of the human element of the story, it's quite interesting. But I'll leave it off because this is not a human element kind of thing. I just want to put it out there that she's well known, she's well respected, and you know it's she has this thing that she's talked about a lot in the past, is that you really have to think about whether you even want to create the system in the first place, right? Who is it going to benefit? Who is it going to be used on? Is it different than the people who are going to benefit from it, right? Who owns the data, right? What is it going to be used for, and how could it be misused? These are all good thoughts to think when you begin on a project. So I think that's a good place to leave it, especially because of time constraints. So for those of you that are interested, there is a lot to explore on this area. I am by no means an expert, but some things that I can give you to kind of explore is the first couple of bullet points are kind of white paper sorts of things that walk you through a lot of concepts and give you a good idea of the lay of the field. The third bullet point is the ProPublica article that I scrolled through ultra quick for you about the Compass system and its impacts. And last is the keynote, the opening keynote address of the NeurIPS conference just a few days ago. So it's by Charles Isbell, and so it's absolutely all about this stuff. It's also ridiculously corny and silly, and it is maybe the most oddball kind of TED Talk-ish sort of thing you've ever seen in your life. And it's really quite a nice way, once you've done a little bit of the reading, to go and watch that keynote will be very beneficial, because the keynote goes through keynote kind of assumes you have kind of a working knowledge of this sort of stuff. But I think that if you went through those white papers, the first two, and then hit the keynote, you would understand all the concepts being thrown at you fast and furious. All right, so thank you so much for your attention. I hope you all have lots of fun. We're getting down to the wire. I hope that the quarter's going really well for you guys. Bye.